Welcome students. Today in this session we will see some applications of the conditions what we learned yesterday in our previous video. So here we will see how to use those conditions in solving or finding some other values of pairs of linear equations in two variables, and then we shall go for the actual algebraic method. Okay, so here let's see some application of these conditions of solvability. So let's begin now. So here I kept the questions and I wrote here this topic here, applications of conditions for solvability of system of linear equations. Okay, so quickly we will learn some application which is very important, one must learn, and this type of question they usually ask in examination as well. So the first question here, find the value of k for which the following pair of equations has unique solution. So yesterday only we learned if you remember, three conditions were there. The first condition was unique solution, second condition was no solution, and the third was infinite many solution. And accordingly we learn synonyms for those three conditions. Unique solution we call consistent and intersecting line, and for no solution we use the term inconsistent and parallel lines, and for infinite many solution the terms were consistent again and coincident lines. So that we learned and we discussed yesterday in our previous class. So here the condition, the first condition given, unique solution. So using this condition we want to find the value of k. Okay, so the equations is given here, kx, so this k is unknown which we want to find out here, plus 3y equal to k minus 3, the first equation, 12x plus ky equal to k, second equation. So two equations are given, and from this, using this unique solution condition, we will find the value of k. So let's see how to find solution. We have equation kx plus 3y is equal to k minus 3. So this is our first equation, so we can mark equation 1. And second equation, it's 12x plus ky is equal to k. This is our second equation. So we got both the equation. Now after writing this equation we will go for the condition. The condition is unique solution. Okay, so we'll write here, since the given equations has unique solution. Okay, this condition we must write, it is given here. Unique solution, therefore we will make use of that condition what we learned yesterday. So for unique solution, if you remember, it was a1 divided by a2, then b1 divided by b2, and this ratio is not equal. No, so this is for unique solution. Let me quickly tell you, for unique solution, the condition was a1 a2 b1 b2 not equal, and for no solution, it was a1 a2 b1 b2 c1 c2, this equal, but the third one is not equal. and for infinite many solution, all were equal, all are equal, a1 a2 b1 b2 equal to c1 c2. So these three conditions which we learned yesterday, today we will see their application. Okay, so this is the first one, unique solution a1 by a2 is not equal to b1 b2. Now let's substitute the value here, and here again we know this a1 a2 are nothing but the coefficient of x in both the equation. Okay, so if you say here in first equation coefficient of x is k and the coefficient of x in second equation is 12, so this is a1 a2. Similarly b1 b2 are the coefficients of y in both the equation. So first equation coefficient of y is 3 and second equation coefficient of y is k. So this is b1 b2, and this constant term, look here, there is no xy, so these constant terms are c1 c2 that we know. So let's substitute a1 a2, k by 12, k by 12 is equal to b1 by b2, 3 by k, 3 by k. Next step, see, now we'll do cross multiplication, k into k, you'll get k square 12 into 3 36, and we know k square 36, we want to find the value of k, so we can write here k is equal to, no, k is equal to 36 will come under square root because of this square. When you remove a square from here, so you'll get a square root on right hand side, so this is what, and 36 is the square of 6, we know. And one thing one must know here, when we remove a square root, always we should write plus or minus, plus or minus, meaning you will get 36 by either squaring plus 6, you will get 36, or squaring minus 6, this will also give you plus 36. So both plus 6 and minus 6 square will give you plus 36, this is plus 36. So that's why when we remove square root, plus and minus we used to keep. Okay, so k is plus or minus 6, both the value we got here, right? Now we can say this plus or minus 6 is the value of k, what the question was asking to find. So k we found here, therefore I can write k is plus or minus 6. So this is what the question was asking to find out, so we got. Okay, so k equal to plus minus 6, simple. So this is how we find unknown value k here using conditions of solvability. Okay, so simple type question they will ask, and this is how we find out. Okay, now let's move on to the next question of the similar type.